In this video, we're going to look at how to solve a systems of equation using a graph. By the end of this lesson, you should be able to identify the solution from both a graph and a table. Remember that many real-world situations can be represented by systems of equations. All you need to be able to do is to be able to write or generate two equations in order for it to be considered a system. So let's take a look at the following situation. Suppose you're thinking about buying a car, and car A costs $17,655, and you expect to pay on average $1,230 per year for fuel and repairs. Car B costs $15,900, and the average cost for fuel and repairs is $1,425 per year. After how many years are the total costs for the cars the same? So we can write two equations for this one. We can write an equation for car A, and we can write an equation for car B. The equation for car A would be y equals 1,230 x plus 17,655, because the cost per year is 1,230, so that would be times x plus a one-time fee of $17,655 for the car that you're buying. The second equation would be set up similar to this one, except it would be 1,425x plus 15,900. And so here we have our two equations, and once we have these two equations, we can solve them using a systems of equations. So we can solve them by graphing them, we could solve them by using a method known as substitution, or we could solve them using a method known as elimination. The only thing that you need to make sure that you do before you start solving them is make sure you know what you're solving for. So the question says, after how many years, so x would have to represent the number of years, since the cost per year, so x would be number of years. Are the total costs the same? So y would have to be the total cost. Once you have the equations written and you know what it is that you're looking for, you know what x is, you know what y is, then you can begin to solve both of these equations. Remember, to solve by graphing, you're going to graph both equations. You're going to figure out where they intersect. The solution is going to be that point of intersection. This point of intersection is an ordered pair. And so once you identified that point, you want to use your ordered pair, the x and the y from that point, and check it in both equations to make sure that the solution that you have is correct. From a table, if you're making a table of values, you're going to look for the point that occurs in both tables. So you're going to look for where the x and the y values are the same in your two tables. So in this table, off to the side, we see that the point 3, 2 is the point that occurs in both of our tables. So this would be the solution here. Okay, so let's look at the following situation. We have two tables, and so we're going to look at the solution and we're going to compare the two tables. So let's start with this. So our first point here is 0, negative 7. If I plug in 0 for x to get out negative 7, followed by negative 6. 1 minus 7 is 6. Negative 5, negative 4, and negative 3. I want to look at my next table. So my next table, my first point would be negative 2. Negative 1/4 times 0 is 0, and 0 minus 2 is negative 2. My next point, well, in order to get this next point, I would take negative 1/4, I would times it by 1, I would subtract 2. Well, negative 1/4 times 1 is negative 1/4, minus, I can't subtract 2 from this, so I'm going to change this so that it's 8 over 4, and that gives me negative 9 over 4. So my next point is negative 9 over 4. To get the next point, do the same thing, so negative 1/4 times 2 minus 2. Well, 2 times negative 1/4, that's negative 2/4, or negative 1/2. Again, I can't subtract 2 from that, so I'm going to change that to 4 over 2. And so my next point would be negative 5 over 2, or negative 5/2. I do the same thing for my next one, so that's negative 1/4 times 3 minus 2, or negative 3/4. I multiply it to the top. Minus 8 over 4, so again I can't subtract 2 from that, I got to get a common denominator. This would be negative 11 over 4. And then my last one would be negative 1/4 times 4 minus 2. Well, negative 1/4 times 4, that would be 4 over 4, or negative 1 minus 2, and that would be negative 3. So I've got my points there. What you see is that in the table, we see that the point 4, negative 3 occurs in both. So my solution for here, based off the table, is 4, negative 3. But let's check the graph. So let's graph both of these lines. So if I graph both lines, I'm going to start the first one at negative 7. There's my y-intercept. And that has a slope of 1, so up 1 over 1. Remember that we want to graph as many points as we can possibly graph, so that when we do check our solution, when we do look for it, we can clearly see where they intersect. My next one would start at negative 2. Remember, it has a slope of negative 1/4, so that says to go down 1 and right 4, down 1 and right 4, or up and to the left, up and to the left. And what we notice here is that when I graph it, I can see where they intersect. My point of intersection is right here, and that point is at 4 and negative 3. So we've checked it. We know that 4, negative 3 is the solution from both the table and the graph for these two equations. The final way to check is to take the point 4, negative 3 and plug it back into both equations. So my y is negative 3. So in my first equation, y equals x minus 7. I plug in negative 3 for y. I'll plug in 4 for x, and I simplify it. Negative 3 equals 4 minus 7. 4 minus 7 is negative 3. So since I have the same thing on both sides, I know that that's true. That's a solution. In my next one, y equals negative 1/4 x minus 2. I do the same thing. So negative 3 is y. 4 is my x. Negative 1/4 times 4 is negative 1. Minus 2 is negative 3. So I end up with the same thing on both sides here. So I know that 4, 3 is my solution. Again, we always want to check just to make sure we didn't make a mistake somewhere along the way. Okay, so let's start by graphing these two. So we're going to graph them. This one starts at 2. So first line starts at 2. It has a slope of negative 2/3. So remember that even if it's switched, the coefficient in front of x is always a slope. So this says go down 2 and right 3. Down 2 and right 3. Down 2, right 3. Or go up 2 and left 3. Up 2 and left 3. Up 2 and left 3. I went back 4 on this one. Let me fix this real quick. You can always check to make sure that your graph is correct, because if your graph is wrong, your solution is going to be wrong. Alright, that's better. So we've got my graph for my first line. I need to graph the second line. Remember that we can graph this one directly from point and slope form. There's no need to change it. The point for this one would be 2, 6. X is 2, y is 6. Remember, we don't include the minus signs when we're pulling that point. So if you forgot that part, make sure that you're good there. And then this says we want to start at 2, 6. So I'm going to put my point at my first point at 2, 6. And the slope for this one is 2, so that says go up 2, right 1. Or go down 2 and back 1. And you want to try to get as many points as possible. That way we can verify the solution. And if you notice, we see a point of intersection. Our point of intersection is at 0, 2. We always want to check that point. So I'm going to take my first equation, and I'm going to plug in my point. So my x was 0, my y was 2. So I should have 2 equals 2 minus 2/3 times 0. 2/3 times 0, that part would end up canceling out. So we would be left with 2 is equal to 2. So we're good there. Again, it has to be the same thing on both sides. I check my next one. Y minus 6 equals 2 times x minus 2. My x was 0. My y was 2. 2 minus 6 is negative 4. 0 minus 2 is negative 2, and negative 2 times positive 2 is also negative 4. So that would be the same case there. So we're good on that one. Let's check our last one. Our last one is we have 2 lines. Both of these are in standard form, so I want to change them. So change the first one. I'm going to subtract 3x on both sides. I get negative y equals negative 3x plus 9. Divide everything by negative 1 so that y is positive. And we get y is equal to 3x minus 9. So I'd start my graph at minus 9. My slope is 3, so go up 3, right 1. Remember to get as many points on there as you possibly can. Okay, my next one, again, I'm going to subtract x on both sides so that I get it in slope-intercept form. I would have negative y is equal to negative x minus 1. Divide everything by negative 1 so that y is positive. And we get y is equal to x plus 1. So I would start at plus 1. And 1 is my slope. So that's up 1 over 1. Again, once you see where they intersect, you're good to, you don't have to really put any more points down. Just, again, you want to make sure that your line is as accurate as you can possibly make it. So if it's a little off at the bottom, that's okay. You're looking for their solution, so the solution for this one would be at 5 and 6. Again, you always want to check it. So I check it in the first one. That's 3 times 5 minus 6 equals 9. So 15 minus 6 equals 9, and that's true. And then I have 5 minus 6 equals negative 1. Negative 1 equals negative 1, so that's true. So again, you always want to go back and check it just to make sure you didn't make any careless mistakes. Before watching the next video, I would like for you to consider the following statement. How can you find the solution from a graph or table?